good. So please let me know if you cannot hear me clearly. I will try to change the network that I'm using. SNLs is a very interesting aspect of natural language processing, and it's one of the most well-researched areas nowadays. I noticed from the chat, one of you was saying you should make sure not to miss the class on NLP that you previously had. I think, is it with Idris Oshamson, one of them? So sentiment analysis is just a continuation of that. It's just the normal NLP that you have done, the natural language processing. When I was going over the material that we have for you, which we adopted from Microsoft, I realized, because this is our first cohort, actually, we just went through the general overview of the entire curriculum, but we did not have sufficient time to go into every bit and crony of that content. So I realized what we have is not the easiest way for you to understand. We could have made it a bit easier. So actually, I prepared another notebook and slides to explain so that you can understand basically what it is, how it operates, and the rest. Then we'll go over what we have on the notebook. This way, it may be easier for you to understand some of the things, because in the notebook, there is a bit of unnecessary details that makes it somewhat difficult to understand all the concepts. So I hope to finish everything today, as I was very busy within the week, so I may not be able to attend office hours in over the week in the night. Yeah. So you've done many things about NLP. You've done things related to machine translation with rules and rest. So you've done classification with Dr. Shamsuddin, where you, based on certain features, you classify into targets. You can have a number of targets. You have a bunch of things, then you have features, then you have your target. So based on that features, you classify into targets. So that's what sentiment analysis is. It's nothing new. It's what you've learned. The only difference is you are classifying natural text, natural language, the text. And what is natural language actually? What we mean by natural, it means the language we speak. We have machine language, which is mostly zeros and ones and whatever that is structured. And we have natural language, which is completely unstructured text that we speak. That is natural language. So we want to categorize that natural language into opinion, whether the text contains positive opinion, positive sentiment, or negative sentiment. That is what it is. It's nothing other than that. So it's the normal text classification that you, not text, rather, is the normal classification that you've done. Your features here are your texts, and your target is your classes, the positive and negative, or 1 and 0. So it's majorly binary classification. We can have three-way classification where we have neutral, but just see it as just a binary classification. The text are your features, the target are positive, or whatever, and then we are classifying based on the text. We want to know what is the opinion or the sentiment of people. So sentiment analysis, also known as opinion mining, is the process of determining the sentiment or emotional tone of a piece of text. It involves analyzing data to understand whether the expressed sentiment is positive, negative, or neutral. So why is it important? Some of the early application of sentiment analysis is in predicting who will win an election. And this is very important for politicians to know if they are going to win, if they need to adjust. And it's also good for one of the works I did in my PhD is determining revenue of a business. So a business wants to know that based on the people's opinion, will they be able to generate money? That's why you can see most of the times now phones they release what do you call it? A picture, video reviews of it. People keep talking, and then they may even make adjustment based on that information. Why? Because they want to make profit. And then you can also use it for many other things about security and all of that. So it's very important to understand. Some of the most expensive form of research is service, trying to understand what people think. So now it's easier to understand what people think, what people want, their emotions, by just looking at the text they share. You don't have to interact with them directly. That has been taken care of. So analysis involves classifying sentiment expressed in a piece of text into categories such as positive, negative, and neutral. So the process is also the same with what you've done in your classification and also every regression, actually. With the only difference that regression, you are predicting into continuous value, but even here, we can use the adjusted regression to make it into only zeros and ones. So you have to clean data, pre-process the data, because natural language comes with a lot of noise, a lot of things that may not be important. And anytime you have noise in your data, it confuses your machine learning algorithm. It's trying to learn from nothing. That noise is not important at all. But the machine learning will try to learn in something that is not even learnable. You cannot learn from it. So we have to clean and prepare it into a way. Then we have to do feature extraction. Or if you like, say vectorization. That is, we know anytime you want to do machine learning, the computers will only understand one and zeros. This we've talked extensively in classification and regression. So you have to convert this natural text into numbers. So we call that feature extraction. Most of the time people just see nowadays word embedding, because word embedding is the most common form of feature extraction method. But we have others. Then you build your model. That is your classification model, just like you do in ordinary classification, and then you evaluate your model using mostly accuracy, precision, and recall. So this is nothing new. Don't see it as anything. Just imagine, remember the classification you've done and the regression you've done, and just put that knowledge into it. Your features are your natural text. And then in classification and regression, you've done one-hot encoding, right? Or level encoding. So that is the feature extraction, converting what you have into numbers or whatever. So, and here we do back of what we do, what do you call it? TF-IDF, time frequency, inverse document frequency, or we do word embedding, which is the most popular feature extraction method nowadays. So in text processing, pre-processing, we do many things, like, for example, loading text. Everything should be in small letter, because sometimes your computers can have a different representation for capital and small letter, even though when they mean the same thing. So your vector matrix will be very big, and then it's not really important. So your accuracy will be less. And then removing special characters and punctuation, because for machine learning, those have been found to not be very important, but then they also make, if you don't remove them, the special characters, they are not really telling you much in some instances, but then they may also make your feature vector space to be larger. Then we remove stopwords. So I don't know if you know what are stopwords. If you've done them in previous your NLP, stopwords are words that are very common in English language, but they are just there for convenience. Meaning, even without them, anybody can be able to understand what the text is saying, but just it will be grammatically inaccurate. For example, we say the boy is going to the market. So if we say boy going market, almost everybody can make sense out of this. So we don't need D in that sentence. We don't need is in that sentence. So these are examples of stopwords. They appear very frequent, but even without them, you can't understand the sentence. So it's better you remove them, because you are trying to reduce the size of your vector to make it as precise as possible, so that machine learning can easily manipulate that as long as it can make sense. So we remove stopwords. And this, you can also do it. Experiments have shown that removing them yields to more accuracy, because they don't really add much sense to the machine. And then we have stemming or lemmatization. So semi-lemmatization are mechanics that we use to reduce words to their original form. For example, we have removing stop words here. We have removing, we can have remove, we can have removed. They are all from remove, right? So generally, if you leave it as they are, all of them, they will all be represented differently. But no matter how your tenses are, people should be able to understand what you're trying to say. They will understand, but maybe you are grammatically inaccurate. Computer doesn't care about that. It's just about understanding. So we do stemming lemmatization to try and reduce words to their original or root form. So what is their difference? Stemming and lemmatization. When you are doing stemming, you are just cutting the end. The machine, the algorithms work by just trying to remove the end of the word. For example, for this removing, it may just take away ing and put remove without even e. It's not correct, actually, the word, but then all of them will be that way. They will present it as one, removing, removed, and all of that. That's how stem works. While lemmatization is semi-supervised and works by trying to understand the word, and so it can even change the entire word itself to get it now, because some words, when they change, when you are trying to put them in a different form, in continuous form, the words may change. So the methodology try to understand that and refer to that. So feature extraction, this I've also explained a bit. To perform central analysis, we need to represent the text in a numerical format that machine learning algorithms can understand. They are commonly used techniques. We have bank of words, where we put, we remove all unnecessary terms from the word and represent all the words as a collection of word frequencies or presence indicators. I have another slide, actually. I didn't know I had it. I would have updated it. So I went ahead and make a new one just yesterday night. So I saw it in the morning that I have a previous one. So that is a bit of more explanation about this bank of words. We can see it there. And then we have the term frequency, inverse document frequency, that assign weights to words based on how much they appear in the document and how much, for example, how much they appear in a specific sentence, then how much they appear in the entire document. Initially, what was done is term frequency, only the frequencies. How many times does this word appear in a sentence? But then they realize it may not be accurate. A word may appear multiple times in a place and then do not appear at all in the entire document. So we want to know how much does it also appear in the entire document. So that's why TF-IDF is more accurate. Then we have the word embeddings, which is what is currently being used now. Represent words as a dense vectors in high dimensional space, capturing semantic relationship. So, and that is why word embeddings are more popular. They are able to capture semantic relationship, the relationship between these words. All of the bulk of words, the TF-IDF, they assume these words are independent, but we all know that it's not the case in natural language. In natural language, words are related to one another. If the word I start with, the words to follow will be related to the first one. So they have that kind of relationship. So, and that's why word embeddings is state of the art now. And then sentiment classification model, you can build it with any model, just like normal classification. See, the moment you've done your feature extraction here, word embedded, it becomes ordinary machine learning. Even to the computer, it does not know it's dealing with natural language. It becomes normal classification and whatever you've been doing. So see it in this simplistic of term. If you want to go very deep into this things, then you can take it bit by bit and then study on your own gradually. It's difficult to understand everything in a few weeks, but if you have interest and passion on it, then you can continue practicing and experimenting. That way you will understand more. And then the model evaluation, also this one, there is no need to go much into it. As it's the same, we use accuracy, precision, and recall, and we know all the different things, and then we can split our data into training set and test sets. All of this you are already familiar with. So I will stop sharing my screen, then share another one. I will go over it quickly before we go to the book of what we have in the GitHub. Yes. So I presume there is no question actually. Oh, I will take the questions at the end so that we preserve our time. I want to apologize if I'm going too fast. I want to take you the most of this things, especially you are already familiar with it. So it's just to put in a way that you can understand. So the other slide, you don't have it yet, but this slide, it's already in the folder I shared previously. And for the notebook that I will show you, one is also available in the folder, but no. Yes, the one that you already have from the GitHub, you can get it there. Then the one that I will use the very first time, I may share it with you later. So I don't have to go all of this. What is sentence analysis? These are example of sentences. The first one, unbelievably disappointing. We are using words that show not happiness, so it's disappointing. So we say it's negative, and the rest. If the word contains word that show negative sentiments, we classify that word as negative. In fact, let's even start. How do we get these sentences? After starting the sentences, most of the time, we do this a lot in our research group. We recruit people. Some of you here, the fellows, are part of our annotators, and then we give you this word text to read a sentence, and tell us whether you think it's positive, negative, or neutral. That's how the data set is gotten. So we do manual labeling, but you can also use computers to do the labeling for you. So this is an example of a review. So you can extract the the reviews and then use that to manually annotate. So what some people do is, if you want to, for example, use automatic computers to do, since all of these reviews, when you give the review, you have to also give star rating. So some can build a simple classifier that will just say that if a text have 5 reviews, it's positive. If it has 4 reviews, it's also positive. If it has 1 or whatever, it's negative, like that. But this may not be accurate. Somebody may give you a very high stars and then have a bad rating. That's why manual annotation is always more accurate. But you can use this, and it may help, especially when you don't have the resources to do manual annotation that is costly and time consuming. So all of these are different sides of the same thing. Opinion extraction, opinion mining, central analysis, and subjective analysis, they may have a slight difference, but they are all the same thing. I don't know what happened to my slide. I don't open for a long time. All this question mark, I don't know from where. So this is the back of words. One of the most simple, effective, commonly used to represent is in machine learning is use of back of words. When you use this position, we forget about all the structure and everything of the document and just build a very big corpus or dictionary of all the words. And that's why I say back of words. It extracts all the words and put them in as a corpus. So for you to do back of words representation, you need to have the steps. Tokenization, meaning you break each word into tokens, into individual aspect. You can use many things for tokenization. For example, you can use punctuation marks to see that the moment you see a punctuation mark like full stop is the end of a token, or you can even use word spaces to break your tokens into individual words, and which is what happens here, because it's all the words, so you break them by white space actually, so that you can have individual words. Then you build your vocabulary, meaning you collect all the words that you break all your tokens and put them into one vocabulary. Then you do your encoding. So for each document, you count how often each word appears in the document. So for example, now back of words is not very, because it's a bit challenging. Imagine you have okay, I'll stop using the presentation mode so that I can use my mouse. You see this, we have 3 sentences: good movie, not a good movie, did not like. We have these 3 sentences. So if we are to use tokenization or whatever to get our dictionary, we have a dictionary of good here, movie here, not here, a here. We don't have to use good again because we already have you good in our dictionary, right? Then movie, we already have movie there, so we don't have it also. Then did also, and then you see or not, and then like. So this is our dictionary. So imagine we have a very, very big corpus. So you can imagine how long our dictionary will be. So for each sentence, we do something similar to one-hot encoding, meaning to represent this sentence for the computer to understand in numbers, we put 1 if the word is there. If it's not there, we put 0. So you see 1, 1 for good movie, every other thing will be 0. This is similar to one-hot encoder, right? Yes. So this is what happens. So the only challenge of this, which is also the same for, I think, also the one-hot encoding, is you may have a very, very large dictionary, depending on how big your whatever is, your sentence. And also, so I think I presume this is a bit clear. Let me not say more things to confuse you. This is the same explanation. Okay, this explanation about stop words, I've already explained. This, a sentence is composed of words that makes sentence grammatically correct but does not have any weight on the sentence. Words like the like and still, whatever, we call them stop words, and we usually remove them. And you can see even in this sentence, we have a bit of stop word. This A is a stop word, so you remove them so that you can remove the size of your matrix. So, and this is about lemmatization, what's called lemma. All of this we've also seen. Also, we can do part of this tagging where for each word we identify which part of switch in the language is it that is important sometimes, especially when you want to keep the context of your whatever. This is the end of this, and I don't know why it's all corrupted. I haven't opened it in over a year, so I'm not sure why. So we are at full stop 1. So I can take questions now before we look at Jupyter Notebook. For example, code that is not what you have there before going to what you have in your in our GitHub repository. So any question? And my apologies if I'm going at the speed of light. I presume that you are all familiar with this thing. If I relate it with what you already know, that is classification. Okay. I will share my screen again. Just to be sure, am I audible? Anybody can just say yes so that I can.
Yes, sir. You are audible.
Yes, audible, loudly.
Yeah, that's great. So this is a very, very basic, and it's not the most basic actually, but it's a basic example of central analysis implementation. I am not a big fan of what you have in your in our IDE science repository, because I felt it has some things that you can understand the concept without it. So better understand the concepts, then you come back to them gradually. So that's why I have this. My apologies for the noise. So since you've already done just a bit, I have to send somebody away. Talk away. Okay, my apologies for that. I presume because you've done NLP already, and if you are following us, you should have installed NLTK. which is what we'll be using. NLTK is one of the most popular library for natural language processing, NLP actually. We have others, but basically just NLTK. You'll be using mostly NLTK. If you are doing synthesis exclusively, you may also use TextBlob. TextBlob is a refined version of NLTK. Is built upon from NLTK, but just NLTK. If you haven't installed it, you may need to install it using the necessary instruction. Maybe pip install. For me, I'm comfortable with pip, so I install with pip. Pip install NLTK. It will install all your it install everything in NLTK for you, and then additionally, not all resources come with it. For example, you may need to download the list of stopwatches. So if you have NLTK already installed, then you can download stopwatches because you'll be using it to remove the stopwatches. But you make sure that you do this only once. When you download it already, you can just comment it. So it does not try to download again anytime you want to do it. It will not actually, it will tell it's already there, but it will waste a bit of your time. Yeah. So, and all other things are the sklan, because I told you this is the ordinary test classification that you've done. Everything is no difference at all. The only difference is the kind of pre-processing you do, and then how you do your vector representation. That's in this case we are doing. We will be doing, for example, we may be doing a word embedding. There are many word embedding models. There are already existing models that they've been already trained. Actually, word embeddings work by using large amount of data to do the embeddings. Then you have a model for that. When you want to do embedding, the next time you want to do this representation, you don't have to do it over again. You just use that. So normally now people don't even train embeddings anymore. You just use, we have many pre-trained embedding models like GenSim. I haven't used it before. What I was using when I was doing, now I don't do this things anymore that much. It was Word2Vec. So you can use Word2Vec, GenSim, and other embeddings. But for example, if you are doing in a language, for example, in Hausa, then there may not be available embeddings. Then you may need to build your own embedding. But if you are doing in English and most high resource languages, then you don't need to do embedding at all. You can just use a pre-trained model to do that for you. I forgot what is here, but we will see. So here you, after installing your NLTK library, you import all your necessary libraries. So if you remember my slide, it's in numbers, right? So the next thing we do is text processing. And I say we can do things like converting everything to small letter. So yes, all of this is Python. So this is a method that does all of that for you. Even without this, it will work. But because it's a necessary step, and especially because you need it to be accurate, so it's good we do it even if it's in very precise. So this method, pre-process, have some of the common pre-processing activities. So we change every small letter. We use this to remove this regular expression. Actually, if you're not familiar with it, you can still go and read more of it and try. So we remove all punctuation mark, special characters and punctuation marks. And the easiest way to do that is with regular expression. That is this. And then we create our tokens using this dot split. It breaks your sentence into tokens. So you see here, we start with text, the same text, remove the special characters, and then that text is now called tokens. So this text will become our tokens. We'll break it into a vector of our tokens. Then from it, we can remove stopwords. After breaking its tokens, then we remove stopwords. And which stopword we are using? English. We've already downloaded the stopwords, right? We've already downloaded the stopwords. to remove it. How? This is our entire words, tokens, and this is a general way for it. If the word is in tokens, any word that is not in the stop words should be preserved, otherwise it should be dropped. Any word that is not in the list of stop words, you pick it. Else, meaning it's in the stop words, then you discard it because it's a stop word. For stemming, we also have many algorithms, and all of them have advantage and disadvantage. Here we are using the what you call it, Porter stemmer. Is a word stemming based on Porter stemmer algorithm. This is how old it is, 1980. So you can read more of it, and you can also play around with other stemmer algorithms. It's all of them. You'll run them in the same way, like this, one line or two line, to just use them. So you can play around with them, and that's actually how you learn this, to understand how it affects your accuracy and what difference it can give you. Then after you've done all of that, you need to put back. Okay, I will see your question. You need to put back your tokens back into a single string, because here we already break it so that we can do all that is. So now you need to put it back because we already have them like that. So this method is what it does for me. Let me see this. I'm not sure I understand your question. You can rephrase it again. Okay. So we want to see an example of what this pre-processing does for us. So we have example of our text is, I absolutely loved the movie. It was fantastic. So if you call the pre-process method, this pre-process, and pass this data, this text for it, and you print your output, you'll be left with something like this. And I think many of you will not be very surprised about the result. The I is taken out because it's a stop word, and you know we remove stop words. You see, absolutely, the original word is absolute, right? But we cut, because we did stemming, it caught it this way. And in fact, why does it cut it this way? Because if it take only the ly out, then it's possible to have a word that can have absolute, for example. That's not a word, but some word can be like that. It can have ing. So then it has to also do differently for it. So most of the time, this is how it works. We have love. For love, it works perfectly. It leave it as love. And the movie, probably because of this special character, or that is, it assumes it's the word moving, move. So this, you see, this is a challenge here. So it caught it this way, and this fantastic, it also caught it, assuming this is. So actually, there are many, there are more smart ways to do stemming. This may not be the best way, but if all this fantastic become this, then it's okay. It's not a problem at all, because the computers don't really care about what they are. Okay, lemmatization and stemming does the same thing. The only difference is lemmatization does not cut the word. You see this one? Please try it on your own. You see, lemmatization will not cut this word. It will give you absolute here, because it's a somewhat dictionary-based approach containing all the words and their original form. And not maybe even not their original form, different forms. It can be an entirely different word. So that's the difference. So this, we call them stem. But if we are using lemmatization, we call them lemma, the resulting word. But lemmatization and stemming actually does the same thing. Not does the same thing, have the same objective, but they do it in different way. While stemming algorithms have been trained to cut the word, lemmatization replace the word entirely. Yes. So, and you can see here, we are building our vectors, vectorization. So this method built our vectors, and below we see what happens. So for example, we have data of with two sentences. I love the music, comma. These are two distinct sentences using back of word. So if we pass, we call it features, and we pass the data into this library that does our back of words, and we print it, we'll have, this is the vector for the first sentence, and this is the vector for the second sentence. And in fact, I don't even have to go far, because in the second slide I showed you how that it will put all the words as a dictionary, and then it will use zeros and ones to represent the words. So, and this is just a comment. This is whatever. If you are to count 1, 2, 3, 4, 5, 6, 7, I will not verify now. Go and do it on your own. Here we have 7 words. If you are to count the number of words within this and this, you realize you have 7 unique words. Then after building our vector, we are ready for machine learning, right? So this is just a method that built a logistic regression, which is one of the easiest, whatever, basic classification algorithms. It's easy to understand. And then, here I was playing around with it. If we have our data also containing 2 sentences, I hit movie and do the experience is bad, and then we classify we have our labels. Okay, what I will do is I will change this so that I don't confuse the algorithm and yourself. So I love the movie, it's positive, so we give it 1. It was a terrible experience, we give it 0. So 1 for whatever, 1 for it. So this is our data, this is our labels. Okay, I'll come to that. So this is our data, and this is our label. So we already have our libraries to extract our features, what we just sent here. And then we have, not library, method, and then we have this method that it built the logistic regression. So we are just passing our features, these numbers, with their labels, this 0, comma, then 1, this, comma, 0. This is why I'm having this is only with one example so that you can understand. And I'm sure I'm over explaining. I'm sure you've all understood this is very basic. And this is for the accuracy, precision. I recall this is a method that does all of that for you. And then this you're already familiar with the normal test classification, and then you run it to find your accuracy. We have only one example, and the example is the same training example as our test, whatever. So we have a perfect everything. And then, so that is that for what I have. I think this is, I will send this for you. I think this is easy to understand. We have everything that is important. We have the text pre-processing, we have the feature extraction, we have the building the model, we use logistic regression, we have the evaluation. So this is it. But the data we will get, we may need much more than this pre-processing. And that is how the RU data science that is based on Microsoft notebook is. So I felt that it's too much. So if we start with it from the very beginning, I may be bombarded with questions. So let's start taking it gradual, so that if I go there, I can rush, and the rest you've already understood what the basic principle is. And then when you have more problems, I'm confident that when you read on your own, you should be able to. Yes, Madam Anthony, if I understand correctly, if you are referring to, and there's no anywhere that I know of any limit for the text variable. It can be any number, if I understand correctly. In fact, this is just a small example. We can have bigger examples. And also, I will give you certain answer. You've already done this with Shamsuddin. So actually, I have not been using it. Then I realized it's cheating. Actually, to me, it's cheating, but that's how it is. During the days of older generations, they go to the library and spend hours trying to study, get books, and all of that. If they are to be told that somebody can still use his mobile phone to just be browsing all the books, all the papers, they may not believe. But now that's what's happening. So, and then they may think it's easy. We find it easy since they suffered the move. So, and now also it's the same thing. You can use these generative models for learning. The Bing, Shamsina has showed you how much you can use Bing for that. And then you can also use ChatGPT, which I played around with it recently, and I realized it makes learning and working too easy. So if you are learning, if you are writing your code, it's giving you a lot of error that you don't know why. You can just copy your error, go and paste it there, or your code, it can help you correct the code. If you don't understand what specific code is doing, you don't have to, you can just copy that segment and paste. It will tell you what that is doing in a very simple and clear terms. So it feels like cheating, but it's not cheating. You still have to do it on your own. So that will help you understand. So anything that you don't understand what it does clearly, just copy the code. You don't have to say anything and paste it in ChatGPT or Bing. It will explain it to you line by line, or even token by token. If it is only one line and separated by many arguments and stuff, it will tell you whatever argument does and what happens when you change those arguments. So that way, you can find it very easy. All you need to do is to just put your time and you will do it. So a lot of explanation here. I'm not going to go over them, but you have to install the LLTK library and you have to download this data set and paste it in this, download it to this folder in your GitHub repository that you've cloned, that is now locally on your computer. This data set is quite large, actually, 230 MB, and you can understand how much text we have within this data text. A data set of this kind of text is not a small data set. Jibril, Lukman, go ahead.
Sorry, sir, I just wanted to share my experience while I downloaded it. So I couldn't push it to the repository. They said it was too heavy.
Okay.
Nice. So I had to put it in a different folder to do everything. Then you now put the notebook back into the repo.
Okay. Thank you very much for that. You can also write it down in the group, Telegram groups, in case if some people are not here and they have challenge with that. Thank you very much. So it's quite heavy, and it's you can imagine how much text for a text file to be this big. But you can see 5,000 hotel reviews. So normally this is how natural data comes, especially reviews, hotel reviews and rest. They come with a lot of noise. So you have to do a lot of, depending on what exactly you are looking for, exploratory analysis to visualize your data set, and then reprocessing to make sure your data set is not all noise, or most of the noise is taken out, so it's easy for you. And I don't know, Lukman, since you've already tried, I found out that this, I don't know if it's because I haven't updated my, I'm not using it. I just downloaded repo long ago and just dumped it in my computer. I haven't updated it, pulled anything. So I don't know if there are any changes. Is this what you have in your repos?
Yes, sir, but the folder is empty since we have to download the data set ourselves.
Yes, I know it's empty. So, but this will not work. Or it did not work in my own case, because it's assuming the folder is 2 folders out, but this folder is 1 folder out of where this is. So in my own case, I have to remove the first full stop and the slash to take it 1 folder out. So, and then it works fine. So if you want it as this, then you have to take this data folder out of the NLP folder for it to work. But this is within the NLP folder. So this code will, even if you put the hotel reviews inside that folder, it will tell you HAL does not exist, actually. I don't know if you've encountered that, or it's because I haven't updated my repository.
No, I just used the relative part while doing it. I didn't use the out.
Oh, so then you will not have a single problem. Yeah, if you use a relative, yeah. So you have to take note of all of that. Some of there may be some problems here and there. We need to suit it. So all of this is explaining, I think when we go to that set, we will see explaining what is within the data set. The columns we have about 17 ODR about columns, and explaining whatever. Is it reviewer nationality, total number of reviews? These are the columns, example of columns within the data set. I think we'll just visualize it and all of that. You can just open this data set in Excel and see what the columns are. So we import pandas, we import time because we want to record how long it took the loading data set. It will take a bit of time because the data set is quite huge. And then you just read the data set, and this someone asks this question if you want to use your own data set. So it's normal, you just read the data set and put it in the data frame, depending on which kind of file it is. So I think I'll go back to the notebook. I don't have to explain from here. There may be some explanation here. Please go, you can read them. Let me go back to the notebook. Yeah, so this is, I hope you can see my screen. This is mine, and it took, no, this is wrong. It did not take this. Maybe it already have it somewhere else. That's why it took longer. I know it took around forever, maybe 2 minutes or more than 2 minutes. It may take significantly longer in your computer, since I can be sure that you don't have the same computer. Your computer is not as strong as my own. So if we want to see how our data set looks like, this is it. It's better you open it in Excel. Hotel name, the name of the hotel, the address, total number of reviews, average score, reviewer score, all of this is not available, meaning it's empty. There may be values down. I haven't done that. Negative sentiment, positive sentiment. So meaning the, okay, either from that set, either this data set or is already a labeled data set. So nationality and all of other things. So this is how the data set looks like. If you open it, it's just like an Excel. These are rows and columns. And then if we were to print the shape of it, you can see it has 17 features and 515, even from the name of the dataset, 500,000, over 500,000 examples. So most of these things we'll be doing now is just exploration, looking at what happens what is the dataset actually. Calculate the frequency count of reviewer nationalities. If you remember here, we have, there should be a column about nationality, yeah, here. So we want to count how many people are from Brazil, how many people are from Saudi Arabia, how many people are from all of that. So if we get the value counts, it tells us that from United Kingdom we have this much, and you can see in all of this country we have people like one. So if we want to do our analysis or whatever that this people country, we may not get any sense out of this. So it's even better we drop them. If our analysis, something else at all, has to do with countries, we want to, for example, find out how many percentage of people from whatever, from UK or from which other country is positive, negative, then these countries will not tell us much because there are not sufficient examples. So this is it. But even this is not telling us much because we have 227 different nationalities. So even this is not telling us everything. So we need to know what are the top 10 nationalities. And then we have them here to get the top 10 from index 1 to 11, meaning 10. So you can see, and you can see even the disparity we have here. US have 35,000, which is number 1, and number 10 have only 7,000. So all this is just exploration. This is not sentiment analysis. So when you are learning, practicing, don't confuse yourself with this. All of this is Python actually. The Python, you've done 30 days of Python. And then the hotel that, here we are trying to find the hotel that received the highest number of reviews per country in the top 10 nationalities. So the hotel review, whatever in UK is this hotel, in America, all of this is just window dressing. It's not part of sample analysis. It's just you are trying to understand what your data set is. Even without this, even in Excel, you can do that actually. So don't confuse yourself with that. So, and then you have these hotels, or even all the hotels. So how many hotels, how many reviews do you have per hotel? So you see, for this hotel, we have this total number of reviews, and then reviews found. So it may, maybe somebody have just given it a star rating or whatever, but not write anything in the review. So you may have, when you count the number of rows examples in your data, you may have this, but then the actual one you found is this. And then while there is an average score column for each hotel in the dataset, you can calculate the average score on your own. And then you add a new data frame to hold that, the calculated average score instead of the average score that you already have on that. And then this is, and you can see the variation. What is inside the data set is minus 0.8, and then the calculated is 8.5. All of this, the average score is already, that's why you do it, is already here. We already have it here, but then we want to calculate the average based on our own computation, based on what is actually inside the data, because some may have been missing while crawling data or while collecting the data. And then we determine how many of our reviews are negative, positive, and then calculate how many rows have column that is positive values of positive and negative values of negative. Okay. In our data set, we have this negative, and positive. So we want to count how many are there, and then why is it? We want to calculate how many negative do you have, how many positive do you have, then how many positive do we have that are classified as negative, and how many negative do we have that are classified as positive. So you can do it in a different way. Okay. Actually, we have, we may have to finish this later. This is the first segment. Let me stop sharing my screen. Okay, this is the first segment. I thought I can finish everything today. And that's the end of the segment here. Then you go and take your post-quiz lecture and pre-quiz lecture. So the only thing we do for this assignment with hotel reviews processing data is just we process the data, explore it, and all of that. So for the next notebook that you have, it does the actual sentiment analysis. I think we can continue with that later and maybe come over this again and follow it slowly. I know I rushed too much because of the time, so we can stop here. Everything we do here is we will come over this again during the next office hour, which I don't want to do, but I have to do. So that's the end of this notebook. So in my notebook, I also have that of the next one because we have two notebooks actually. We have hotel reviews 1 and hotel reviews 2. So what I just showed us is the hotel reviews 1, and the next one is. So the next one is hotel reviews 2. So I think we'll stop here, and then when we come for next office hour, because this is not much actually, it's only a couple of lines to see the sample analysis. You can go over the exploration again in case if you have any questions. Yeah, this is you can. I will not send you my notebook because even copying and pasting in the notebook, empty notebook that you have within there will help you understand some things. When you do it and then you face problem in running, then so now what you will need to do, and you've been doing, you read the explanation, then you copy this or you try to type it again in your notebook. Then you play it, you see what happens, then you go to the next line, read what happens, and then you copy and paste. That's how you've been learning all of this. So you do that. You already have this. What I can send you is the one that I shared the first time, which is not here. It's my own. Then I will put within the folder. So, and then let me show you something that I'm referring to. Okay, can you see my screen? Can you see my ChatGPT?
Yes, we can see.
Yes, sir.
So I just copy the code from there. I'm imagining I don't know what it's doing, or I don't want to waste my time Googling and trying to understand every bit of it. So if you just paste it, I don't know if some of you are doing this. So it goes ahead to tell you the code snippet is remove support, takes review as input and whatever. However, the code refers to a variable cache which is not defined in the function to implement the support function. So you see, even it's understand that it's a snippet and maybe something is missing. So it will give you all of that and it explains it clearly, every bit of it, of what it does. And you can do this for any line of code. So sometimes when you are studying and you fall into a hiccup, I think it's okay. You can just use this, copy, you paste it there, or if you are having an error that you don't know how to solve, then you can copy the code. For example, if you copy the code, just go down and then you paste the error. What the error is. It will automatically try to tell you what it thinks the error is, and then rewrite the code for you in a way that the error is not there, if it's from your writing or it's from a library you are missing or whatever. So this will help you in learning, and before you know it, you may not even need its help. So I think we are on top of the hour. If there is any question, otherwise we bid adieu. So any question? Nobody is.
I think there was a question regarding maximum number of, is it words or characters or whatever. Yesterday, I think when we were discussing about machine translation, we came across maximum source length and maximum target length. So some NLP tasks require that the length of the sentence be stated. So maybe that's why they are asking. So in sentiment analysis, is there also that restriction on the number of words that is supposed to be in a sentence, or there is none?
Okay, actually, I think I already answered Malan Tanimi. If I understand the question, that's what I said. If I understand the question correctly, there is no limit.
Oh, okay.
So do you have anything? I don't know, you are here. Do you have anything to add or share with them? So I will share my slides and notebook with you, the one I use